Hello, I'm Cinzia Soresina, and I'm a researcher here at the University of Trento, working in the field of mathematical biology. I'm going now to introduce you the track Modeling, Statistics and Analysis of Biosystems, which is part of the curriculum Mathematics and Statistics for Life and Social Sciences. The content of the track are methods and mathematical models used in different areas of biology. And in particular, we are going to see deterministic and stochastic models of biological phenomena with application, for instance, in epidemics, population dynamics, but also molecular networks or degenerative diseases. And this content interfaces different areas, so theory, simulations, and data analysis. In particular, we are going to see, for instance, ordinary and partial differential equations and stochastic processes. We are going to exploit computer simulations and also go back to the biological problem and to the data. So the statistical analysis of the data. The goal is to combine these three aspects to obtain qualitative and quantitative results and insight on the biological phenomena. This track is also characterized by the possibility of doing stage or interact with institutes, research centers, and companies. At the local level, we have a very good environment here in Trento because there is the Bruno Kessler Foundation close by, the Edmund Mack Foundation in San Michele all'Adige, and the COSBI in Rovereto. At national level, I would like to mention the Istituto Superiore di Sanità or Istituto Zooprofilattico Sperimentale and also the National Research Council. This track is also characterized by a strong interdisciplinarity, and not only within mathematics. As I said, we are going to combine theory, different approaches, simulation and statistics, but also this track has strong connection with other disciplines. So like biology, of course, computer science, chemistry, but also social sciences. So if you don't know what a mathematical model is, so think, for instance, to the basic pillars of scientific research, such as, so you should be able to work in a controlled environment, controlled condition, and you should be able to repeat the experiments. But these two pillars do not apply to several complex natural phenomena. Things, for instance, to an epidemics. You don't want to experience an epidemics another time. And in case this happen, it won't be with the same conditions. So the goal of the mathematical modeling is then to provide a tool in this regard, so to identify the most important variables and interaction in the system, but also to, once you have your model, you want to study the properties of the model, so combining qualitative analysis with simulations, and also to try to reduce the model to simpler versions. You also want to verify whether your model reproduces the characteristics of the phenomenon. You want to have a good model, so with a good agreement to the biology. And you want also to apply the model to obtain prediction and forecast, and also to explore the effect of possible control measures. So this is the general framework. Some possible applications are, for instance, in epidemiology. In this case, we can have different formulation of the model. For instance, you may consider compartmental models. So you divide your population into different compartments and you write down differential equations that describes the behaviors of the individuals. There is also another approach, more computational approach, is called agent-based models. And I want to mention in this case the Bruno Kessler Foundation. They are very strong in this sense. Another possible field of application is ecology, in particular population dynamics. We can model from the individual level to ecosystem and landscapes, and or species interactions. Another interesting application in this context are the biological control, so the control of invasive species, in particular thanks to parasitoids. So these are two examples, so the Drosophila suzuki, which is a pest here in Trentino, and also the Asian bug. And both can be contrasted and fight with the introduction of a parasitoid. So in this case is a wasp. And this can be done in collaboration with the Edmund Mack Foundation in San Michele. In another context, more towards medicine, the modeling techniques from the other two field of application can be exploited and are also similar to the for the analysis of molecular networks. In this case, we have, for instance, a figure extract from a paper done in collaboration with Cosby in Rovereto, and we are have cells, so it's a study of the immune therapy for prostate cancer, and we are studying cells and molecules. So these are some possible applications. Of course, the mathematical modeling in biology is not limited to these examples. Here are some titles of recent theses. You can pause the video and have a look. So more on the practical level. So the track, Modeling Statistics and Analysis of Biosystems, is composed by core courses and complementary courses, and they reflect the different aspects that I mentioned to you. So more on the theoretical part, so with partial differential equations, for instance, more on mathematical biology courses, scientific computing, simulation, data analysis, stochastic processes, or statistics. This study plan has to be completed with 3 courses, a foreign language, and the thesis. And if you keep this structure, your study plan will be automatically approved. You can also propose a different study plan, and this has to be approved by a committee. This track, I should say that this track has much in common with the other tracks in the curriculum, mathematics and statistics for life and social sciences. If you are more interested in interdisciplinary topics, you may also have a look to the Master in Quantitative and Computational Biology. What is required to start with this track? Of course, basic knowledge in ordinary differential equations, probability, statistics, and numerical analysis. And useful skills are programming skills. In case you don't have, you should be willing to learn. And also you should be, useful skills are basic knowledge in functional analysis and partial differential equation. Very important and fundamental is the interest in applications and especially biology in a broad sense, so natural sciences, and also the willingness to interact with people with different backgrounds. So often projects are developed in a multidisciplinary team, so you should be willing to interact with non-mathematicians. The ability to do it will be developed during the track, during the master, but at least you should be willing to do it. What can you do afterward? Of course, you can go for an academic career with a PhD in Italy or abroad. So several students had positions here in Trento or also abroad in prestigious universities. And afterwards, you can, there are several postdoc positions in this field, especially on specific projects. Other possibilities are, for instance, pharmaceutical companies. So they now, they have a modeling team. For instance, a colleague of mine is the team leader of the modeling team for this well-known company in Germany. And also the skills that you are going to develop during the track, the master, are useful also for other areas far from biology, not only in biology. So the modeling applies also to other contexts. So to conclude, if you need more information or if you have questions related to the track, you can contact the advisor of the study, Andrea Pugliese. This is his email address, but you can also contact me. Next year I'm going to teach the courses Mathematical Biology and Advanced Topics in Biomathematics. And you can also have a look to the laboratory Mathematics for Biology and Medicine. So here you have the QR code to link to the website. And with this, I thank you all for the attention, and I hope to see you next year in Trento.